Hi, and welcome to AskRose Homework Help livestream. Tonight we're going to be doing FOIL and factoring equations, which kind of follows along from last week where we were working more with systems of inequations and like linear inequalities and those type of things. So today we're going to be working on foiling, which is kind of the expansion of multiple multiplication terms or into what is called a polynomial, and then later factoring out trinomials to turn them back into the factored states. So we're going to get started here in just a second, and we're going to go ahead, switch over to my slides. There we go. Awesome. Okay, I'm going to move us to the second slide here. Okay, so the very first thing we're going to start with, what is FOIL? And that is a fantastic question. FOIL is an acronym, and FOIL stands for, if I switch to my pen color here, if we write out FOIL, F-O-I and L, FOIL is a method of multiplication for these kind of two terms here and here. And it stands for first, outside, inside, and last. And it's a really good way to remember the steps to things. I'm going to walk you through now kind of why that is our acronym and why that's the way we do things. So first things first, I'm going to copy these terms over here. If I write 3x plus 1 times x minus 8, both of these, the separate multiplication terms, implying that like essentially whatever happens in the parentheses is done first. So we need to change the way that we're doing our distributive multiplication in order to make that work. So I'm going to switch my color here, hopefully, to make it a bigger point if we make it red. So the first thing we're going to do is find our first terms in each one. And that's going to be this 3x and this x. And so change back to black. So then our first term is going to be that 3x multiplied with the x, which is 3x squared. So that's our first term. So we've got that one done. Then we're going to go to our outside term. I'm going to change my color here again. Let's do a green. So then our outside term is going to be the two outside numbers. So we're going to take this first term of this one, and the second term of the second one, which is the 3x and then the negative 8, because those are the two outside terms if you look and act like it's all the way on the outside of the equation. So if you multiply that 3x with that negative 8, we're going to get negative 24x, and then that step is done. So now we get to look at the inside, and as you might be guessing, that's going to be multiplying the two inside terms. Do that in blue here, so we're going to take that 1 and that x and multiply those, and that's our inside term. And so if we multiply the 1 and the x, we just get a plus x. And then finally, we get to do the last, and the last is the only two terms that we haven't multiplied together yet. I'm going to see if I can do that in a purple. It's going to be that 1 and the negative 8. And so that 1 and the negative 8, if we multiply those together, becomes just negative 8. So then, take this and... Sorry.
Can't really see it.
Oh, I see. Sorry. Hold on. We're going off the screen. I'm going to rewrite it a little bit lower there. 3x squared minus 24x plus x minus 8. And there we go. We should be able to see that. Sorry, my viewport is blocking it there a little bit. And then we can simplify this out in order to make it just a little bit cleaner. So the 3x squared, there are no other x squared terms, so that just gets to say. However, the negative 24x and the positive x, we know from our kind of basic algebra rules that these are like terms, so we can combine them. So we can turn this into a negative 24 plus the 1, and then the x's on both. So that just becomes negative 23x. And then we don't have any other non-x terms, so we just keep the minus 8. And so our whole term, after we FOILed it out, is 3x squared minus 23x minus 8. Awesome. Okay. So this is just a general reminder. If you have any questions about what we're doing, or if you'd like me to explain more, please say something in the chat. Let us know if there's anything you'd like me to cover more in depth, or perhaps give another explanation of. We can run through it again. But if not, we're going to move on to our next example problem. Okay, so I'm going to let you guys start first, and I'm going to give you probably about a 20-second head start. We're going to be doing essentially the same thing, just FOIL, which is our first outside, inside, last. I'm just going to write the initials here. I'm not going to actually write it out. But if you guys want to take about 10-20 seconds and start to do that, then I'll start about 20 seconds behind you, and can get to doing that myself, so that way you can see if your work is matching up with mine. Alrighty, I'm going to get started on my end now. So I'm going to take the two first terms, which is the two x's. It's going to be an x squared. And then I'm going to look and say, look, we did the first terms. Now I'm going to do the two outside terms, which is the x and the -1, which multiplied together is -x. And then, so then we've done the outside terms. Then I'm going to do the two inside terms, the -1 and the x, which is again, when multiplied, just -x. We've done the inside terms, and then we get to do the last terms, which is the -1 and the -1. And negative times a negative is a positive, so that's just going to be +1 at the very end there. That should all be visible, I believe. Yes, it looks like it is. Okay, excellent. And then I'm going to go ahead and simplify this one down just a little bit more, because that we can turn that into x squared. We have a -x and a -x. We know that's really just minus 2x, because they're a like term, they can be combined. And we just bring down that +1 as well, because it doesn't have an x term attached to it. So our total final answer for multiplying out x minus 1 multiplied by the other quantity of x minus 1 is x squared minus 2x plus 1. Again, if you have any more questions, feel free to submit them in the chat or to our jot form online through our website at www.askrose.org/worksheet. Also, if you have any questions and you'd like to come back after the stream, you can always submit them there and then call our call center, and we'd be happy to take your call and have a tutor help you walk through those problems on your own, so you can go a little bit slower at your own pace. Great. So I'm going to move on to my next example here. A little bit more tricky. This time we're doing a 9x plus 1 multiplied by a 9x minus 1. Throws a little bit of a curveball in there. We've got the plus and the minus, but otherwise the terms are the same. So first thing we're going to do is do our FOIL step here. So we're going to do our first, which is going to be the 9x times the 9x. 9 times 9 is 81, so we've got an 81x squared, and that's the first term. And then we're going to do the outside terms, the outside terms, which is the -1 times the 9x, so we've got a minus 9x, making sure we don't go outside our view window here. And then we've got our I, which is the inside terms. So if we look at the first two inside terms, that's the 1 and the 9, which is a positive 9x. And then we're going to do the last terms, which in this case is just the +1 times the -1. So that's going to be minus 1, which does look like it fits. Okay. So the really cool thing about these terms is that you might have noticed, oops, so we did that. You might notice here actually that something that's cool that's happening is when we simplify this, right? If we simplify it down, we say 81x squared, because there are no other x squared terms, and then we look at all of our x terms, and we see we have a -9x and a positive 9x. So both of them cancel. And we're just left with a 0x, or you don't need to write a 0x, because it's just multiplied by 0 is 0. And then we could just carry down the -1. So the really cool thing about forms that are multiples that are in this kind of form factor, where it's a plus and then a minus, it's the same thing, it's called a conjugate, where you just have a minus sign instead of a plus sign, or a plus sign instead of a minus sign. You can actually drop the middle terms. You don't have to worry about it. You can only multiply the first ones and the two last ones, and that will actually give you the correct answer. because it turns out that when you multiply the middle terms, because of the plus and the minus, when they get multiplied by the outside and the middle, they end up dropping out. And so this one, the correct answer is 81x squared minus 1. Okie dokie, so that looks pretty good then. I'm going to go ahead and move on to our next slide. Okay, so this is kind of our final foiling question for you. You're welcome to try and solve it along with me if you'd like to. In fact, I'll probably give you guys like a 10-second head start or so that way you can work on it and think about kind of how you want to start this problem. Just to remind you, I'll say FOIL again. You're going to hear it very many more times. FOIL is still a useful trick you'll use in college. It's a really great acronym to learn how to multiply out those kind of two terms in parentheses by another two terms in parentheses. It's very, very useful. You will use it forever. It's fantastic. Some of your teachers may have like different acronyms that they use for it, but it all means the same thing. If you're handed two kind of parentheses in this form factor, this will always work. Okay, so presuming that you guys have started the problem now, maybe you've gotten stuck, I'm going to go ahead and start. Something you might notice that's unique about this problem is that our factors are in a different order than they were before. Because right in our normal form factor, if we wanted to write this the other way, we had like a 4x plus a 4 times a 2x minus 5, right? Because this is all addition, and it's all getting added by each other, which means we can move it around in any direction. So in this case, when the problem was given to us, they left it as the 4 plus 4x times 2x minus 5, all in parentheses there. So it's just a little bit of trick you can do with algebra, and you can move the terms around. And actually, even so, you can do the problems the same way. It shouldn't matter. It shouldn't affect it too much. Your terms are going to be in a different order, but when you combine them, they turn out to be the same thing. So in this case, we'll demonstrate that. I'll start by going first. So if we do the first, that's the 4 times the 2x, which is only going to be an 8x. No squared on this first term because we don't have an extra x there. And then I'm going to do the outside terms. That's the 4 times the negative 5, which is negative 20. So that actually is going to end up being like our last term with no x. Then we get to do our inside terms. This is the 4 times the 2, and then an x on both terms. So those get multiplied together to be an x squared. And 4 times 2 is 8. So this is plus an 8x squared. And then we get to do our last terms. I'll check them off here as we've gone. We've done the first outside and inside. Now we're going to do our last, which is a 4x multiplied by a negative 5. The 4 and the negative 5 still make negative 20, but this time we've got the x on it. So it becomes negative 20x. Oops. Negative 20x. Which I believe is visible. Yes, it looks like it is. Okay. Great. So now we're going to go ahead and simplify this one down. Now your teachers are going to have different ways of doing it. I like personally to move it so that my greatest x terms are kind of at the front of the equation. And because it's all added or subtracted, we can kind of move those terms around in any order because all of the operations are the same. So I'm going to take this 8x squared and I'm going to put it out the front just because I think it looks better to write it that way. And generally, mathematically, that's how your teachers will want it written, with kind of the biggest term coming first. And then we're going to look for any other terms. So I'm looking for x terms, and I see I've got a negative 20x and a positive 8x. Negative 20 plus 8 is negative 12. So I've got a negative 12x as a term here if we combine those. And then I'm looking for a term without any x's, and we've just got the negative 20. So there we go. We have a negative 20 at the very end, and our final answer is 8x squared minus 12x minus 20. Really cool thing about this one as well is if you wanted to, you could factor this down, and it looks like you could pull out a 4 if you wanted to in this one, which could simplify the terms if you wanted to simplify it even more. But if not, this is totally fine. Most of the times your teachers aren't going to require that, but if they do, now you know how. You should just be able to pull out a 4 I'll actually demonstrate that quickly, just so you guys can see what that looks like. If we pull a 4 out of the first term there, my pen is not wanting to write. Interesting. Let me try again there. Hello, can I write? I apparently can't write down there. That's interesting. So if I pull a 4 out, we've got the 2x squared, because we pull a 4 out of the 8, and then we subtract 3, because we're pulling 4 out of the negative 12. 12 divided by 4 is 3, and then the negative 20 divided by 4 is negative 5. So essentially we can pull that 4 out of the whole term, and these two terms are actually the same thing. Just one is a little bit more simplified because we pulled out a common factor from all of them. Some of your teachers may want you to express it that way, but in reality, of course, they are the same answer. They are equivalent. We've just done some rearranging. Okay. If you guys have any questions about FOIL, or you have any problems you'd like us to do specifically for this, now is the time to submit them, or you can submit them a little bit later and we'll get to them, but we're about to move on to our next topic. So just a reminder that you can always submit stuff to the Jot form as well and call us starting in about 15 minutes at 7 p.m. Eastern Time. That's when our call center opens, and then we're open till 10 p.m. Sunday through Thursday, and we're always happy to take any of your science and math related questions at any time during that. Our tutors would be more than happy to help you, especially with questions like this. This is everyday stuff we see. It's really important. It's really great to do. Awesome. Okay. So I haven't seen anything in the chat as far as I know, so I'm going to go ahead and move on to our next question, or our next slide rather. Okay, so this is a very important question. How do we undo this? How do we get rid of the FOIL? What if we start with a trinomial and we, trinomial, by the way, I'm using that terminology. A trinomial is just like an x squared term plus something here, and then a x term plus something here, and then like a constant c without an x term. But it really could be any number here. So that's kind of an example of a trinomial, and you'll see a lot more as we get into the next slides. So the way that we undo a trinomial, and we kind of put it back in that form with the parentheses, is called factoring. And there are lots and lots of different ways to factor. Your teachers are probably going to teach a different one than I'm going to do. But tonight we're going to use a pretty common one. It's usually fairly reliable, and this is called the box method. It's the box method of factoring. There are many ways to do it, but this one is mine. We've got a couple box memes here for you, a box GIF, and just a box. Quite excellent, if I do say so myself. Anyway, so we'll actually move on to the next slide with our example. Okay, so as you notice here, I've got myself a 4-square box. You can go ahead and draw one for yourself if you're following along at home or you're taking notes, something like that. So I'll give you some time to do that, as well as write down the problem, which is we're going to factor x squared plus 5x plus 6. Okie dokie. I've given you some time to do that. Now we're going to factor this, and so factoring, the first thing we're going to do using the box method is we're going to write down the first and the last term inside the box. So we're going to take that very first term and write it in here, our x squared, and then we're going to take our very last term and write it in here, in this box. Then we've got to find these two corner boxes, right? We've got to find this one and figure out how we do that. So the way we're going to do that is we're going to actually multiply these two boxes. So if we multiply the first and the last term, then x squared times 6 equals 6x squared. And we're going to find the factors of this that add up to make this middle number 5x, which I'm going to do in a different color here just to emphasize it. So we want the factors of 6x squared that equal, if you add them up, to 5x. And that probably sounds a little bit tricky if you haven't heard those terms before, so we're going to walk you through more than a couple examples. So we've got a 6x squared here. First thing I'm going to do is list factors of that. So the factors that I know are we've got a 1 and a 6, and a 2 and a 3. And of course these are all multiplied by x, so that way we get our x squared term. Because the 2 times 3 will equal 6, and then the x times x gives us an x squared. Same thing for the 1 and the 6 and the x and the x. So these kind of groups are our factors. Okay, so now we're going to be looking for, of these factors, these kind of things that multiply up to create this number, 6x squared, we're going to be looking for the ones that if we add or subtract them in certain ways can get us to the 5x here that we're looking for in the middle. So I'm going to change my ink color again. So we're looking for 5x. Now if I do, let's say, we're going to do a like 6x plus 1x, well that equals 7x. So that's not great because we don't want a 7x. And then if we do like a 6x minus a 1x, we can get a 5x. And you might be thinking, well that sounds great because that's a 5x and that's what our answer is in the middle. But they've done something very tricky here. That's not actually quite the right answer. And the reason is because of the symbols that they're using in our equation. I'm going to jump to blue here. So because both of the signs here are addition, the second sign will determine kind of whether both of your terms are the same or not. If the second sign is a plus, both of your terms are the same, which means we need to have all pluses all the way across the board. So because this is a minus, this one doesn't work. That's not an option. And then the 6x plus 1x, well that's 7x, so that's not really an option. So I guess we need to start looking at our 2x and 3x. So we just established that because these two are the same, they're both pluses, we absolutely need a plus here. So we can only add them, we can't subtract them, so if we do a 2x plus 3x, 2x plus 3x is 5x. So that works, that equals our middle term, and that means what we can do is put in a 2x in one of our boxes and a 3x in another one of the boxes. Okay, so now we're ready to actually use the box method for factoring. So what we're going to do is we're just going to look for a common factor in each one of the boxes, and we're going to write it here on kind of the left and upper sides. And I'll go ahead and do that in, I think, purple. So if we have kind of this first column here, the x squared and the 3x, I'm going to look for things that are in common between it. Is there a 3 in the first one? Well, no, so there's no common factor for the coefficient. But there is an x in that column. But there's only one x in the second box, so we can only have one x overall. So that one's just going to be an x. And then we're going to move over to the second column, and the 2x and the 6. Is there any common factor between a 2x and a 6? Well, there's no x, because there's only an x in one of the boxes. But a 2 can be pulled out of a 6. So you can find a common 2 between both of them, right? Because if we pull the 2 out, that works, and if we pull the 2 out of the 6, that also works. And then, of course, our sign, as we saw before, is going to be addition, because both of these are addition. So x plus 2. And that's going to be our very first term. This is going to be one of our terms. And then let's look at the rows. So if we go across the first row, we've got an x squared and a 2x. The thing that this shares in common is just an x. So we're going to have an x over here. And then again, if you really look at our signs, we've got a plus and a plus, so we're going to have a plus. And then we get to look at common terms in common factors of the second row, the 3x and the 6. The only thing that we can pull out that's a common factor is a 3. So we're going to pull out the 3. And then this ends up being our second term, so I notate that very weirdly. So our final answer here is going to be x plus 2 multiplied by x plus 3. And that is completely factored, x squared plus 5x plus 6. That's what it turns out to be. That is the way to do that problem. Whoops, I think I hit it back. There we go. Go ahead and square that in. That's our final answer. Alrighty, now we're going to move on to our next problem. Okay, so this example is factoring x squared minus 4. So first things first, we're going to walk it through it like we did the last one. We don't have a middle term in this one. We only have a first and a last term. So I'm just going to go ahead and add those to the boxes. We've got an x squared and a negative 4. And then just like before, I'm going to go ahead and multiply them together. So we've got a negative 4x, and we're looking for the factors of negative 4x that create our middle term. And we don't have a middle term with an x, right? What's it supposed to be? Well, if you remember earlier, we had a problem that does this, and the middle term is just 0. So we just need to find two factors that turn out to work out to 0 when we add or subtract them. So the first thing we're going to do is figure out things that add up to 0 from negative 4. So our factors of negative 4 are going to be like negative 4 and 1 and 1 and negative 4. Actually, I'm going to go ahead and erase these because we're very close to my actual box there and I want to leave room around that. Switch back to my pen. Alright, so I'm going to list them over here actually on the side, which I should be able to see. Yeah. So negative 4 and 1, 1 and negative 4, and then like a 2 and a negative 2. So we need to find the things that if we were to add them, and something important to note about this one, I'm going to tell it to you here. It's not completely obvious, but it will be in the future. I'm going to explain a little bit more, that this sign is minus. And what that means is our factor term needs to be like 1 plus and 1 minus. So if we actually look at adding these, if we have a plus 2 and a minus 2, plus 2 minus 2, and these all technically have an x on them because they become negative 4x squared, plus 2x and minus 2x is equal to 0x, or just 0, right? These two cancel, which means those are the ones we want. So I'm going to go ahead and put a 2x here and a negative 2x here. And then again, we're going to go look through the first column. So we look through the first column for things that we can absolutely pull out of both because they end up being the same. We've got an x in both, so I'm just going to have an x here. We look at the second column. I'm going to look for common factors again. This time we've got a 2. And then I'm going to go look at the first row. In the first row, we've got an x squared and a 2x. What's the common factor? We can pull out an x. And then in the second row, we've got a negative 2x and a negative 4. Pull out another common factor. In this case, it's going to be a negative 2. So we've got kind of an x minus 2 and an x plus 2. The other really cool thing about factoring is, of course, if we end up adding these two last terms that we have when we factor out, they should equal our middle number. And, of course, this x plus 2 and x minus 2, that plus 2 and minus 2 are going to end up equaling 0, which is the same true there. So if I write this out here as x plus 2 and x minus 2, you'll notice that this is another pattern. This is a conjugate, which is something that we multiplied out earlier. And because it's a conjugate, if we were handed something like this to multiply, remember how earlier I said we didn't actually need that middle term because it was going to work out to be 0, so you could just find the first and the last. So then you just have an x squared minus a 4, x squared minus 4. So anytime we see something in this form where it's x squared minus something else, right, especially if this if it's a square, so that's like 1, 4, 9, 16, any of those kind of combinations, this will always, always, always work itself out to be x plus something and x minus something. And that will always take that form because it's a conjugate. Okay, it's 6:58 here, so I'm going to start wrapping up. We've got just one more slide. I'm going to let you guys write this down if you want to work on it at home, or if you'd like to even call during our hours and work on that. You can absolutely call a tutor live, and they would help you work through this one. I'll get you started here because it's a little bit trickier because we've got this 4. We've got two options here, kind of. We can either start and go straight to the box method and put the 4x squared and the 2, and then work on multiplying our last terms and finding all the factors. Or if you wanted to simplify it a little bit, you can pull out a 2 first, right, and make it 2x squared minus 3x plus 1. Either one is correct, depending on what you want to factor. And then your final answer, if you factor this, you just have a 2 on the outside, also multiplied by your 2 answers. Awesome. So thank you guys for tuning in so much to our live stream. I've been having a great time. I hope you've been having fun. This is some really useful stuff. It's really great for you to know. FOIL and factoring are really fundamental parts of algebra. Absolutely. If you want to ask more questions or submit questions to our Jot form, you can either submit questions for next week's live stream by choosing the live stream tab, and generally that's better to do on a Tuesday night, so we're more likely to see it, or kind of Wednesday during the day. Or you can kind of tweet them at us if you wanted to, but then there's a chance we don't see it because it might get lost in Twitter. But otherwise, please follow us on social media. Please go submit questions to our worksheet and then call our call center, and we'd be happy to call, email, or chat with you. We're open 7 p.m. to 10 p.m. Eastern Time on Sunday through Thursday, and we're mostly open for math and science questions, and we're happy to help grades 6 through 12, from pre-algebra to geometry to calculus, anything in there. So yeah, feel free to call, and thank you so much for watching. Have a great night.